Hi, welcome to my tutorial on simplifying surds. What we see at the top there, it says a number written exactly as its square root or in a square root is known as a surd. Now that's not strictly always true. Root 7 is a surd. The reason is because if we cannot rationalize root 7. The number is an irrational number, so it will go on forever. It won't recur, or it can't be written in the form of a fraction. That is a surd. So root 7 is a surd. However, let's say you had root 4. Now root 4 I can rationalize. I can write root 4 as an integer, 2, because the square root of 4 is 2. So it should be clear to see that all the prime numbers are going to be surds. There are more. However, if we think about the two laws of surds, we can use that to simplify lots of expressions involving surds. The basic laws of surds are as follows. If you've got root A and you're timesing that by root B, that is the same as root A times B. The same with division. If you've got root A and you are dividing that by the root of B, that is exactly the same as the square root of A divided by B. And those two laws are what we use to simplify lots of expressions. Let's have a look at a couple of examples here. I've got 3 examples to do. I want to simplify root 20. Now when we talk about simplifying a root of a number, what we're trying to do is to get the part of the root out of here. So what we're trying to do is we're going to try and use one of our laws to simplify that and leave it as a surd in its simplest form. So what we do is we say, well, what two numbers can multiply to give 20? Well, I could have root 4 multiplied by root 5. And using our first law, we know that root 20 is equal to root 4 times root 5, because 4 times 5 gives you 20. So now what I can do, we've already seen that root 4 can be rationalized. So this can be taken out of the root, so I'm left with just 2 root 5. Root 5 cannot be simplified, so this is in its simplest form. Example 2. We've got a fraction here where we've got a root on top of it. Now we could play around with this root 40 here, because I could now do root, let's say I could do here root 5 times root 8. That multiplies to give us 40. But none of these here can be rationalized. So that's no good. It's not going to help us simplify anything. But what else could we look at? Two numbers that multiply to give 40. We could try root 4 multiplied by root 10. Now we know root 4 can be rationalized. So on the top there, I could write this as square root of 4 is 2 root 10 over 2. Now what you could see is 2 and can be divided by 2, so 2 into 2 goes 1, so this can be simplified to root 10. The last one, example 3, this one's a little bit more complicated. We've got 2 roots here and we're adding them together. Now you can't add different roots together. You can't do that. So it's just like having x add y in algebra. We know we can't do that. And it's the same with roots. So here, what we could do though is we could simplify these. So if I look at the first one here, in example 1 I had root 20, I know equal to root 5. So I could write root 20 as 2 root 5. Now if I can make this so I have a certain amount of root 5s, then I can add the same roots together. So just like if I had 2x add 4x, it gives me 6x. If I've got 2 root 5 and perhaps 10 root 5, I can add them together. So let's see if we can do that with this one. Well, here I could change this into root 5 times root 16, because 5/16 give me 80. Root 16 can be rationalised, because the square root of 16 is 4. So what I now could have is I could have 2 root 5 added to 4 root 5. If I add those together, I get 6 root 5. And I've now simplified this right down to 6 root 5. Can't go any further because root 5 cannot be rationalised.